In this example, we have a plane traveling at an airspeed of 400 kilometers per hour with a compass heading northwest. So let's kind of draw that. And it also encounters a 60 kilometer per hour wind from the north. So sketch it and find the magnitude and direction of the resultant vector. So let's draw it out. They're heading at an airspeed of 400 kilometers per hour with a compass heading northwest. So just kind of draw a little compass here. That's north, west, east, south. So it's heading northwest, it's heading up in this direction up here. So the plane vector is going to be heading northwest at 400 miles per hour, or kilometers per hour. Okay, and that means that this angle here is going to be a 45-degree angle, because northwest is halfway between north and west. It then encounters a 60 kilometer per hour wind from the north, so that means the wind would be heading south. Add a 60 kilometer per hour clip, and what we want to figure out is what is the resultant vector, and I'm going to try to color code things here a little bit. So we'll have the wind be blue. So what we're going to do is we're going to find the x and y components of each vector, add them together, and that will tell us what the resultant vector, or what the plane, is actually doing. So the wind vector is actually quite easy. There's 0 for the x component. It's not heading left or right at all. It's just going straight down to the south. And so then the y is negative 60. It's negative because it's going down. If it was going up to the north, we'd call that positive. The plane, we're going to have to do a little bit of math to figure that out. So to find the x component of the plane, this is the adjacent side, the x side is the adjacent side, the 400 is the hypotenuse side. So we're going to do cosine of 45 equals x over 400. And then I'm going to type into my calculator 400 times cosine of 45, and I get 282. Looks like I didn't give myself quite enough room here. 282.8. And that's going to be negative because it's heading left, which we'll call negative. If it was heading to the right, it'd be positive, just like we're working on a coordinate plane. And then the y direction is going up. That's the opposite. So we do sine of 45 equals x over 400. And if you remember your special right triangles, you know that the x and y are the same, so the y is going to be 282.8 as well. So our resultant vector, I'm going to do in green here, would be, if we add up the x component of the plane vector, the x component of the wind vector, and then the y component of the plane, and the y component of the wind. And that's going to give us our resultant vector. So we get negative 282.8 plus 0 is negative 282.8. And positive 282.8 plus negative 60 is 222.8. So our resultant vector is negative 282.8 and 222.8 for the x and y components of that resultant vector. So it asks us to find the magnitude and direction of that vector. That means so what this is telling me down here is that the vector is going to have an x value of negative 282.8 and a y value of positive 222.8. So this is going to be our resultant vector right here. We need to find that magnitude. So to do that, we're going to use the Pythagorean Theorem. 222.8 squared plus negative 282.8 squared, and that's going to equal the magnitude squared. So I'll type this into my calculator. And when I do that, I get 360.0 for our magnitude, kilometers per hour. So that's going to be our magnitude is 360.0 kilometers per hour, and our direction, we're going to find this angle, and so I'm going to do tangent inverse of 222.8 over 282.8. And when I type that into my calculator, I get 38.2 degrees. So, we can say this direction a couple of different ways. We can say that it's 38.2 degrees north of west. So, north of west, because it's to the north, or toward the north from the west bearing. Or you could also say it is whatever 180 minus 38.2 is. Let me type that in here. I get 141.8. So you could also say it's 141.8 degrees for our direction. Either of these would work. I would imagine the most desired answer is 38.2 degrees north of west. So that is our plane problem. So on this problem it says, suppose a pilot wants to fly directly east at a ground speed of 225 miles per hour, but there's a wind from the northwest at a speed of 40 miles per hour. What airspeed and compass heading should the pilot select? So the first sentence is pretty vital that you understand what this is saying. It says, suppose a pilot wants to fly directly east at a ground speed of 225 miles per hour. So that is telling us that let me change my pen a little bit here, that this is the resultant vector. It wants to travel at a ground speed of 225 miles per hour directly east. So our answer is going to be due east at 225 miles per hour. And what we have to do is figure out what two vectors were added together to give us that resultant vector. So I know my resultant vector is going to have an x-coordinate of 225 and a y-coordinate of 0. So there are two different vectors acting together that will give us this resultant vector. One is a wind vector, and the wind vector is heading, let's see, but there's a wind from the northwest, so that means it's heading southeast at a speed of 40 miles per hour. So the wind is heading 40 miles per hour to the southeast. So that tells me that this angle here is 45 degrees. And then there is the airplane vector. And this vector is going to have to go something like this, because it's got to negate the downward force of the wind so that we can go due east, and it's got to be traveling to the right so that we can get up to 225 miles per hour. So what we need to do is figure out what are the x and y components of this airplane vector, and the way we're going to do that is by solving this equation with our wind vector plus the airplane vector is going to equal this resultant vector. So we're going to basically have to work backward on this one. So let's figure out what the x and y components are of the wind vector. And to do that, we're going to do cosine of 45 degrees equals the x value over 40. And when I type that into my calculator, cosine of 45 times 40, and I get 28.28. So we'll say 28.3. And then the y value is also going to be 28.3, because it's a 45, 45, 90 triangle. It's going to be negative 28.3. Because it's heading down in the southern direction, so that's why it'd be negative. So, I know that if I take this 28.3 and I add in the x component of the airplane, I should get 225. So let's write out that equation here. We've got 28.3 plus something will give us 225. So that's a fourth grade math problem to solve here. We're going to subtract 28.3 from both sides. And when I do that, that tells me that the x coordinate of our vector is going to be 197.7. So 197.7. Oops, sorry, I did my math wrong. Not 187.7. It's 196.7. See if I can erase that. I can't. 196.7. Sorry about that. And then I know that if I take negative 20, so I'm going to now look at the y values. So if I take negative 28.3 plus whatever this is, I need to get 0. So negative 28.3 plus, we'll say question mark again, equals 0. So if I add 28.3 to both sides, that tells me that it should have had 28.3 miles per hour in the northern direction. So I have my magnitude, or I have my x and y components of our airplane vector. It asks us what airspeed and compass heading should that be. So it's asking for magnitude and direction. So I need a little bit of room to figure this out, so I'm going to give myself some room here. And I have a vector. I'll redraw the airplane vector. It's going to look something like this. And I know the x value is 196.7, and the y value is 28.3. So if I want to figure out the magnitude, I'm going to do the Pythagorean Theorem. 196.7 squared plus 28.3 squared. And that equals c squared, so I square rooted both sides, to kind of eliminate a step. So let me plug this in my calculator. And when I do that, I get 198.7 for my magnitude, and that would be in miles per hour. So I've got my magnitude, 198.7 miles per hour. Now I need to figure out my angle, theta. So to do that, I'm going to do tangent inverse of 28.3 over 196.7. And I'll type that in my calculator. And when I do that, I get a theta value of 8.2 degrees. So I would say 8.2 degrees north of east. And there we have it. We have our airspeed, magnitude, and compass heading, 8.2 degrees north of east. So this is the third problem on our worksheet, talking about George and Sarah pushing a go-kart. George pushes with a 20-pound force and Sarah with an 18-pound force. And their angles with respect to the line behind the cart are shown in the picture I have drawn down there for you. And it says, what are the magnitude and direction of the resultant force, and who contributes more forward force? So, we have George and Sarah pushing on this cart at different angles. What we're going to do is we're going to look at the George vector, the Sarah vector, and when we add them together, that's going to be our resultant vector. So let's look at the George vector, and that's going to be a vector with a magnitude of 20 pounds of force at an angle of 50 degrees. So we're going to find the x component and the y component. That says x, not y. The y component of this vector. So to do so, we're going to do the cosine of 50 degrees. That's going to equal the x component over 20. And for the y component, we're going to do the sine of 50, and that will be y1 over 20. So I'll type these into my calculator, and I get for x1 12.9 for x1, and I get 15.3 for y1. So my x and y components for George's vector are that he's pushing in the horizontal direction 12.9 pounds of force, and vertically 15.3 pounds of force. Let's take a peek at the Sarah vector. So Sarah's vector looks something like this. This has a magnitude of 18 pounds of force, and it has an angle of 65 degrees. So we need to find the x component, we'll call this x2, and the y component, we'll call that y2. And so the same idea as what we did with George, we're going to do the cosine of 65 degrees, and that's going to equal the x2 over 18. And for the y component, we're going to use sine, because the y is the opposite of 65 degrees. 65 degrees over y2, or excuse me, 65 equals y2 over 18. So I'm going to plug this into my calculator, and for x2 I get 7.6, and for my y2 I get 16.3. So what we're going to do is we're going to add these two vectors together, and that's going to give us our resultant x and y component for the resultant vector. And one thing I'm noticing right now is that my x for Sarah should actually be negative because it's heading in the left direction, so that would be a negative value. And we should know that they're heading, George and Sarah are pushing opposite horizontal directions, so they should cancel each other out somewhat. So what I'm going to do is I'm going to add the x components together, and then I'm going to add the y components together to get my resultant components. So 12.9 plus negative 7.6 is 5.3, and then 15.3 plus 16.3 is 31.6. And so we have our x and y components of our resultant vector. And so now what we need to do is find the magnitude and direction. So my resultant vector is going to have an x, I'm going to just write it up here, an x value of 5.3 and a y value of 31.6. So I need to figure out the magnitude, and I need to figure out the direction, or theta. Excuse me. So the magnitude, I'm going to use the Pythagorean Theorem. 5.3 squared plus 31.6 squared, that's going to equal c squared. So let me type that in. And when I do, I get, for the magnitude, I've been using m in my other examples, so I'll be consistent here. So for the magnitude, I get 32.0. So 32.0 pounds of force. And my direction, we do tangent inverse of 31.6 over 5.3. So my angle is going to be 80.5 degrees. So I have my magnitude and I have my direction of the resultant vector. And then the last question says, who contributes more forward force? So what I'm assuming is that forward force means the force that's heading up, because they're trying to push this cart forward. So whoever has the most vertical component, and that looks like the winner would be Sarah. Sarah contributes 16.3, and George only contributes 15.3. So Sarah contributes 1 more pound of force in the forward direction. And there you have the George and Sarah problem. This question says Captain Jack Sparrow sails for 10 hours at a speed of 14 knots, which is nautical miles per hour, at a heading of 72 degrees north of east. Then he turns on a heading of 57 degrees north of east and travels for 2 hours at 11 knots. Find its position north and east of its starting point. So, we have Captain Jack Sparrow, and he's traveling along at a 72 degree angle at 14 nautical miles per hour for 10 hours. So, what that means is he has traveled a total of 140 nautical miles. And this is a 72 degree angle. And then once there, he turns and heads 57 degrees north of east for 2 hours at 11 knots. So he's going to turn and go at less steep of an angle for 22 nautical miles. And this angle here is 57 degrees, believe it or not, based on my picture. So our resultant vector is going to be where Captain Jack Sparrow started to where he ended. And so just like every vector problem, we've got 2 vectors that are added together. We're going to add their components and find the components of the resultant vector. So let's start with this first trip, which I have in red. That is a 72 degree angle. And the magnitude is 140 nautical miles per hour, or nautical miles. And so we're going to find the x component and the y component. So to do that, I'm going to use trig. I'm going to do cosine of 72 equals x1 over 40. Sorry, 140. And then sine of 72 equals y1 over 140. So I'll type those into my calculator, and by a stroke of magic the answers appeared here. The x component was 43.3 and the y component is 133.1. So let's look at the second part of his journey, and that was a 57 degree angle, and it was for 22 nautical miles. So let's find the x and y component of this vector. So same idea, we're going to do cosine of 57 equals x2 over 22 this time, and then sine of 57 equals y2 over 22. And so we'll calculate these. And our x and y components for the second part of the trip are 12.0 for the x and 18.5 for the y. So to get the resultant vector, we're going to add the x and y components, and I'll write that up here. That 43.3 plus 12.0, so 43.3 plus 12.0 will give us 55.3. And the 131 or 133.1 plus 18.5 will give us 151.6. And so it asks to find his position north and east of its starting point. And we did that. He is 55.3 nautical miles east, and he is 151.6 nautical miles north of where he started. And there you have it. In problem 5 on our worksheet here, it says a boat leaves point A on the south bank of the river and heads at a 70-degree angle with an engine speed of 15 knots. However, the eastward force of the current carries the boat, so it actually travels at a 50-degree angle. So what this tells us, it actually travels at a 50-degree angle with the shore. That tells us that the resultant vector has a 50-degree angle with the shore. The initial boat vector has a 70-degree angle with an engine speed of 15 knots, and then there's a second force, or vector, an eastward force of the current, but it doesn't tell us how fast the current's going. That's what we need to figure out. But it does tell us the direction. So let's kind of draw this out and figure out what this looks like. We have a 70-degree angle at 50 knots, so our boat vector is going to look something like this. 70 degrees, and it's 15 knots. And so we're going to figure out the x and y components of the boat vector. And then we have our current vector, and that's heading eastward, so that means it's going to the east. And we don't know how fast that's going, so we'll just kind of put a little question mark there. But I do know, if I write out the component form of this vector, I do know that the y value is going to be 0, because it's not going up or down at all, so I kind of have that figured out. And then my resultant vector, so what actually ends up happening is a 50-degree angle, and we don't know the current, or I'm sorry, we don't know the resultant force, and so this would be, we'll call this x3, y3. So we're going to start by figuring out the x and y coordinates, or components, excuse me, of the boat vector. And to do that, we're going to do the cosine of 70. That equals x1 over 15. And then we'll do the sine of 70. That would equal y1 over 15. So I'll plug that in my calculator. And by the power of editing, I have my x and y components of the boat. I just did 15 times cosine 70 to get 5.1, and then I did 15 times sine of 70 to get 14.1. So I know when I take my boat vector plus my current vector, I get my resultant vector. So that tells me 14.1 plus 0 will give me 14.1. And then I'm going to do 5.1 plus whatever this is will give me whatever that is. Well, I've got two missing pieces. I can't solve for that right now. But what I do know is I have my y value, my y component of the resultant vector, and I have the angle measure, which is 50 degrees. So what I'm going to do is I'm going to figure out the hypotenuse using sine, cosine, or tangent. So where y3 is, I'm going to kind of cross that out, and I'm going to put 14.1. So I'm dealing with the opposite side, and I want to find the hypotenuse. That's going to tell me I'm going to use sine. So sine of 50 equals 14.1. 6.1 over, say, h for the hypotenuse. And then I'm just going to, in my calculator, take 14.1 divided by sine of 50, and that will give me my hypotenuse. And that is 18.4. So I know the hypotenuse side here is 18.4. And now that I have that, I can figure out my x3 side. So I'm going to do cosine of 50 equals x3 over 18.4. So I type that in, and I get 11.8. So it asks me how fast is the current. That means I need to figure out this stuff right here. And I know that if I take 5.1 plus the speed of the current, I get 11.8. So basically all I'm doing is 11.8 minus 5.1, and that would give me 6.7. So how fast is the current? The current's 6.7 knots. And then how fast does the boat actually travel? Well, 18.4 knots. That's how fast the boat actually travels. That's the magnitude of the resultant vector. There you have it.